If you are watching this video for the first time, make sure you are subscribing to Anantha Lakshmi Academy. Once you click on the subscribe button, you will see a bell icon. If you click on that bell and click on all, you will get to know whenever I upload a video. This will send you a notification. Hello everybody, welcome back to Anantha Lakshmi Academy. Today we are going to deal with the concept that is related for us to solve exercise 3.2. So this is polynomials part 2. If you are directly coming to the video part 2 and not gone through part 1, I'll be attaching the polynomials playlist in the end card. Please go through it to have a better understanding because all the introduction and concept is covered in first part. So today we are going to deal with how do we work with polynomials. So first thing we are going to learn is different kinds of polynomial. What do we call them? How do we call them? That is what we are going to learn. So when we said p of x is equal to ax plus b, we said any expression in terms of x of the form ax power n is known as polynomial. Within polynomial we have types. Let's figure out what are they. Next, again, p of x is equal to ax square plus bx plus c. And p of x is equal to ax cube plus bx square plus cx plus c. If you have understood how am I writing this, this is x power 1. The degree of first polynomial is 1. The degree of second polynomial is 2. The degree of third polynomial is 3. So let's write the same here. Degree is equal to 1. Degree is equal to 2. And here the degree is equal to 3. When the degree of a polynomial is 1, that is known as linear polynomial. Alright. What is a linear polynomial? When the degree of a polynomial is 1, that is known as linear polynomial. What do we call when the degree is 2? That is quadratic polynomial. Quadratic polynomial. I am just putting ditto marks over here. Alright. Next, when degree is 3, it is known as cubic polynomial. Ma'am, what do we call when it is 4? We just call them as polynomials. Alright. For only these three things, we just have the names. It's just the same thing. When you have x power 2, we call it as square. When you have x power 3, we call it as cube. And what do we call when it is x power 4? X power 4 itself, right? It's the same case. When you have x power 1, it is a linear polynomial. When you have degree as 2, it is a quadratic polynomial. When the degree is 3, it is a cubic polynomial. Alright. So when we are discussing about the zeros of a polynomial in the earlier video, what do we thought? Well, let us consider p of x is equal to, for a linear polynomial, what do we thought? For some value of x, the expression becomes 0. That is known as 0 of a polynomial. That's what we have understood, right? I'm trying to figure out the value of a 0, okay? Let k be the 0 of polynomial p of x. What does that mean? When you call some term as a 0 of a polynomial, then p of that term becomes 0. That is a k plus b is equal to 0. Then what does k become? K is equal to minus b by a. For a linear polynomial, the 0 is in the form of minus b by a. What is minus b? Nothing but, which is equal to minus, what is b? B is a constant, right? By a is coefficient of x. This is how we work with polynomials. This explanation is under the explanation working with polynomials in your textbook. So in order to figure out the zero of a linear expression or a linear polynomial, we can, when an expression like ax plus b is given to you, you can directly find the zero by using this formula minus b by a. Okay, so for an expression, say for suppose y is equal to 2x plus 3, what could be the zero? As per this, the zero is equal to minus b by a, right? Minus constant. What is the constant? 3 by 2. Isn't it? Minus 3 by 2. Yes. So now I want to check this. How do I check this? By using geometrical representation. How do we represent these expressions geometrically? Using graphs. Polynomials is the chapter which deals with graphs. So even before studying the graphs in 10th class, we guys are aware of the graphs, how to draw the graphs, x dash, y dash, positive numbers, negative numbers, the scale, 1 unit is equal to 1 centimeter, 1 unit is equal to 5 centimeters, like that we used to write, right? I hope you guys are familiar with the graphs, because I cannot put time in this chapter to explain the graphs. If you want to understand graphs of so and so class, just let me know in the comment section, so that I would do a detailed video on how to draw the graphs. All right, so now that you understood the zero by using this formula, k is equal to minus b by a, now we are going to do it using the geometrical representation. What are we going to do? Geometrical representation. Okay, what is given? Y is equal to 2x plus 3. The 0 is minus 3.2. So somewhere it is like minus 1.5 if I calculate the thing. Okay, in order to draw a graph, now that we have to verify it using the geometrical representation is what I said. But in order to draw a graph, we need x values and y values, x, y coordinates. If you are familiar with graphs, you will understand these terms. X, y coordinates we need to know. So here it is given as minus 1.5, right? So let me consider a value from minus 2. All right. So for x is equal to x, y and x comma y values, I am trying to sort out. X is minus 2, minus 1, 0, 1 and 2. For these values, I am trying to draw the graph. All right. When x is equal to minus 2, so what does y become? Y is equal to, when x is equal to minus 2, y is equal to 2 into minus 2, minus 4 plus 3, minus 1. Alright. Next, when x is equal to minus 1, what does y become? Y is equal to 2x. 2 into minus 1 is minus 2 plus 3. That is 1. When x is equal to 0, y is equal to 2 into 0 is 0 plus 3. Alright. Then when x is equal to 1, y is 2 plus 3, 5. When x is equal to 2, y is 4 plus 3 is 7. Alright. These are the values: minus 1, 1, 3, 5, 7. If I am to write it in the form of coordinates, how do I write? First x value, then y value, x value, y value, x, y, x, y, and x and y. Those are, what are they called? They are x and y coordinates, and when you write something as x comma y, they are called ordered pairs. Alright. So now, how do I represent this geometrical representation, the graphical representation? How do I do this? Now, so the maximum value of x is 2 and the minimum value is minus 2. And likewise, the maximum value of y is 7 and the minimum value is minus 1. So, now that you know the values of x and y, within the graph, you have to make sure you are covering the maximum and minimum values. Your scale has to be taken in such a way that it covers both maximum and minimum values. All right. So now that we are doing graphs in Anantha Lakshmi Academy, we need x and y axis. All right. What is this? The intersection part of x and y? Origin, which is 0, 0. All right. Next, we have on x axis 1, 2, 3. Then -1, -2, -3. This is x dash. What is this? So I'm trying to cover the minimum and maximum values on the x-axis, which is -2 and 2. But here on y-axis we have the maximum value as 7 and minimum value as -2. So on y-axis the negative part is on the lower side and the positive part is on the upper side, isn't it? Okay. So here on y-axis I am going to write it. This is -1 and -2. But on y positive axis we need a value till 7. So this is going to be 1, 2, 3, 4, 5, 6 and 7. Here, since I do not have a scale or something, my graph may be little, not up to the scale. So in your graphs, you make sure you are doing it rightly. Like 1, 2, 3, you'll have boxes right in the graphs. So you can do that there. All right, this is y dash. So the first ordered pair is -2, -1. How do we mark it? For the value of x -2, the value of y is -1 here. And for -1 it is 1. -1 it is 1. Here -1 and 1. And then for 0, on 0 it is 3. And on 1, for 1 it is 5. And for 2 it is 7. So our graph is going to be like this. All right. This is nothing but a straight line. What is linear? When we call something linear, if you have already gone through my videos, in applications of trigonometry, I said that all the objects that we are going to measure are considered linear. What is linear? Linear is nothing but a straight line. So for a linear one, this is going to be a straight line. Now, this value, okay, let me draw it correctly. My straight line is bending, all right. So now, if you geometrically, when we represent a graph, how do we identify the zeros of a polynomial? The zero of a polynomial when we represent geometrically is nothing but when the graph intersects the x-axis. Intersect is nothing but cuts or touches the x-axis at a point. That is known as zero of a polynomial. When the graph or polynomial intersects x-axis, then the value or the point is nothing but the point, in detail if you want me to say, the x coordinate of point. When graph or polynomial intersects x-axis, then the x coordinate of the point is known as zero of polynomial. Okay, this is about the graphical representation. So here in there is a point where this graph is intersecting the x-axis, which is between -1 and -2. If you draw this graph correctly on the graph paper, you will get this at a point which is nothing but exactly between -1 and -2, which is nothing but this point is -1.5, which is nothing but our -3/2. So the value, the 0 which we tried figuring out for the linear polynomial using the formula is exactly the same as the geometrical representation. So using the geometrical representation, how do we figure out the zeros? When we draw the graph, when the graph intersects the x-axis, then the x-coordinate of that point is said to be the 0 of a polynomial. Alright, this is for the linear polynomial. Likewise, for the cubic polynomial and for the quadratic polynomials also, the examples and graphs are given in the textbook. So it is a dumb rule that for a polynomial, the maximum number of zeros can be same as its degree. Since this is a linear polynomial, we just have 1 0. If it is a quadratic polynomial, we may have 2. The maximum number of zeros is 2. And the minimum number of zeros is, it can have no zeros. The expression may or may not have zeros. Maximum number, if it has zeros, if at all it has zeros, the maximum number is equal to the degree of polynomial. For a polynomial, at most you can have zeros as 0 or which is equal to the degree of polynomial. So what I am trying to say is, if you get to know that there exist zeros for a polynomial, then the maximum number of zeros can be equal to the degree. Alright, if for a polynomial there can be no zeros also. Can there be a polynomial? Yes, we have one such type in our exercise problems. I'll be explaining it in detail in the exercise. So when we represent the graphical representation, the x-coordinate of that point is at which it intersects the x-axis is known as zeros of a polynomial. And for a linear polynomial, there can be one distinct point if the zeros exist, and for linear polynomial, quadratic polynomial, at most two zeros. When I say at most, either 2 or 0 or 1 also possible. Alright, for cubic also at most 3. If you want a detailed note on how the graphs are drawn, this is in detail, very detailedly explained and clearly explained just before the exercise part. The same is explained for quadratic and cubic polynomials as well. Please go through it before we jump into the exercise. I have explained the linear graph, and we will be solving the quadratic and cubic polynomials in the exercise. Alright, so just pause this video here and go through the examples, how the graphs are drawn exactly. For quadratic polynomials, you will get parabolas, up curves or down curves. This is what you will be encountering. And for cubic polynomials, you will have some sort of symbols like this. So there may be 2 or 3 zeros for cubic polynomials as well. So just pause this video here, go through that concept and unpause this video. By then I'll be ready with the exercise problems already listed on the board. Alright, yes, I hope you have already gone through the examples and the concept part that I have asked you to refer in the textbook. Now I am ready with exercise problems already listed on the board. So let's jump into it without any delay. So the very first problem says y is equal to p of x, and we are asked to find the number of zeros of p of x. Within the geometrical representation, I have told you that when the graph intersects the x-axis, the x-coordinate is said to be the 0 of a polynomial. Now here within the graphs there are no points given. They are just asking us to figure out how many number of zeros. What is a 0? When it cuts the x-axis at a point, that is considered as 1 0. If the graph is cutting the x-axis at more points, then you can count those numbers and give the result. All right, so let's do the same in this. So here in the very first bit, the graph is just parallel to x-axis, wherein it is not intersecting x-axis at any point. So this is, since this is not intersecting, for the first one we have 0 zeros, no zeros or no zeros, because this graph is not intersecting x-axis at any point. All right, so for the second one, if you see here, this graph goes on like this and intersecting x-axis at a point. All right, so this particular graph has 1 0, isn't it? Because this is intersecting x-axis at one point. Now here if you observe the third graph, it is like this. How many, at how many points it is touching the x-axis? 1, 2 and 3. So there are 3 zeros. All right, next for the fourth problem, I told you for quadratic polynomials the graph will be like parabola. Here the parabola is intersecting the x-axis at 2 points, hence this has 2 zeros. And when we jump into the fifth bit, this particular graph, it is like a sine curve or a cos curve. So this is intersecting x-axis at 1, 2, 3 and 4. 4 points. So this has 4 zeros. And the last bit is 1, 2, 3. It is touching or intersecting the x-axis at how many points? 3 points. So this has 3 zeros. Very easy, isn't it? The graph is given in the textbook. We just have to write the number of zeros, isn't it? So that part. Now that I hope you guys are familiar with the geometrical representation and figuring out the zeros. All right. Next, let's jump into the second problem, wherein they are asking us to find zeros of polynomial. Okay. Now that we are not supposed to use the geometrical representation, when we say 0 of a polynomial, this expression p of x is going to become 0, isn't it? So let's use the same trick to solve this. So solution, p of x is equal to 0. What is the definition of 0? For some value of x, this expression is going to be 0. If we figure out that value of x, then that is the 0 of this particular polynomial, isn't it? If you are directly coming to this without understanding the concept of 0, I request you guys to go through the polynomials part 1, wherein I have explained the zeros concept very clearly. All right, I'll be placing it in the end card. Please go through it if you are directly coming to this, because without concept you cannot understand. All right, so when p of x is equal to 0, 3x is equal to 0, x is 0 by 3, which is nothing but, so the 0 of a polynomial is also 0 for the first bit. All right, for the second bit, sorry, excuse me. So for the second bit, given p of x is equal to x square plus 5x plus 6. So p of x is equal to 0. This is also, if you are not familiar with the factorization, then this chapter is going to be very, very difficult for you. So please go through the factorization introduction which I have given in the earlier video, or if you are not at all aware of factorization concept, let me know in the comment section so that I'll do a separate video to make you understand the factorization concept. All right, so for this, the multiplication of coefficient of x square and the constant is 6, and the sum of them has to be 5. So I am going to consider this as x square plus 2 and 3 are the factors of 6. When I sum them, it is going to give you a summation of 5. So that is how I am going to do it. X common in the first 2 terms and 3 common in the next 2 terms, which will result in x plus 2 multiplied with x plus 3 is equal to 0. Now how do we solve this? We equate it like x plus 2 is equal to 0, x plus 3 is equal to 0. So x is equal to minus 2, x is equal to minus 3. So minus 2 comma minus 3 are the zeros of the polynomial x square plus 5x plus 6. Alright. So coming to the third bit, it is directly given like the one which we have just solved. So p of x is equal to 0, There he gave the expression as a polynomial. Here he gave it in the factorization form. Just equate it to 0. X plus 2 is equal to 0. X plus 3 is equal to 0. X is equal to minus 2. X is equal to minus 3. So minus 2 comma minus 3 are zeros of polynomial. Alright. The last one is P of x is equal to x power 4 minus 16. Okay, x power 4 minus 16, I am going to write it as x square whole square minus 4 square is equal to 0. Because this is not in the regular, see, if it is a quadratic polynomial, what is a quadratic polynomial? For the polynomial, if the degree is equal to 2, then we call it as a quadratic polynomial. If it is a quadratic polynomial, then we could use the factorization method and get the zeros out. But it is power of 4. So I am trying to figure out other ways. That's the reason I am explaining the fourth bit to you guys. If not, I would have left it to explore on yourself. So this is x power 4. Since we could not solve the power of 4, I am trying to express 16 as 4 square such that it becomes a square minus b square form. Alright, this is nothing but a minus b into a plus b is equal to 0. Isn't it? I am writing down here a square minus b square is equal to a plus b into a minus b. Alright, now when two factors equal to 0, what are we going to do? Equate them. X square minus 4 is equal to 0, x square plus 4 is equal to 0. Now again, x square minus 4 can be expressed as x square minus 2 square, which is nothing but x minus 2 and x plus 2 is equal to 0. That way it gives x is equal to 2 comma minus 2 as zeros, this particular expression. And then x square is equal to minus 4. X is equal to, since I cannot express this in terms of a single digit, I am going to take a square root, the square to the other side, which becomes x is equal to plus or minus 4. The zeros of this particular expression are 2 comma minus 2 and plus or minus root 4. Alright, this is the fourth bit is a bit different from rest of the things. Rest all are quite familiar and similar and easy for you. So that is about first and second problems in this exercise 3.2. We are going to deal with the graphs in next problem. So let's get started with the third problem. Yes, I am ready with the problem listed on the board, the very first one, wherein this is the third problem, first bit. They are asking us to draw the graphs for the polynomials given and find the zeros and justify our answer. So first, even before to draw the graphs, to understand from where to start, what value of x we should start, what value of x we should end, let us try figuring out the zeros by using the expression p of x is equal to 0. That makes x square minus x minus 12 is equal to 0. I'm using the factorization x square minus 4x plus 3x minus 12 is equal to 0. X into x minus 4 plus 3 into x minus 4 is equal to 0. So x minus 4 multiplied with x plus 3 is 0. X minus 4 is equal to 0. X plus 3 is equal to 0, which will result in x as 4 and x as minus 3. So if you look at this, this is giving me understanding, right? These two are zeros. So for the values of this graph, I could start from minus 3 to 4. Why did I do this? To understand from which value of x should I start solving p of x. Alright, so p of x is nothing but our y coordinate. So x, y and xy coordinates, we will try to put them in the here in the graph. So what is it? So for a value of when x is equal to minus 3, what is p of x? P of minus 3 is equal to minus 3 whole square plus 3 minus 12, which is nothing but 9 minus 9 is equal to 0. Alright, when x is equal to minus 2, p of minus 2 is equal to minus 2 whole square plus 2 minus 12. That is nothing but 4 plus 2, 6 minus 12 minus 6. So I am drawing the graph from minus 3 to 4. In order to know the range of the values to solve this graph, I have solved this and doing the same, figuring out the values from minus 3 to 4. Alright. So this becomes p of minus 1 is equal to minus 1 whole square plus 1 minus 12 is equal to 1 plus 1 10. Sorry, 2 minus 12 is 10. Alright. X is equal to 0. P of 0 is equal to 0 square minus 0 minus 12. Alright. Next, x is equal to 1. 1 square minus 1 minus 12. 1 gets cancelled. This is also minus 12. And x is equal to 2. P of 2 is equal to 2 square minus 2 minus 12. 4 minus 2 is 2 minus 12 is minus 10. Alright, x is equal to 3. P of 3 is equal to 3 square minus. Either you solve this along with me or pause this video and try solving by yourself. Alright. 9 minus 3 is 6 minus 12 is minus 6. P of 4 is equal to 4 square 16 minus 4 is 12 minus 12 is 0. Alright. So we got x values from here by solving, and we got the corresponding y coordinates which are nothing but p of values. So let me draw a box for this. X, y, x comma y, which is minus 3, minus 2, minus 1, 0, 1, 2, 3 and 4. What are the values? 0, minus 6, 10, minus 12. What is this? Is also minus 10, right? Minus 10, minus 12, minus 12, minus 10, minus 6 and 0. If I am to write it in the form of ordered by, this is minus 2 comma minus 6, minus 1 comma minus 10, 0 comma minus 12, 1 comma minus 12, 2 comma minus 10, 3 comma minus 6 and 4 comma 0. The same values of x and y I have written in the form of ordered by. Now that we have the values of x and y, we are ready with the values that are needed for our graph. So what is the maximum value of x? 4. What is the minimum value of x? Minus 3. And likewise, what is the maximum value of y? We do not have any positive value for y on y-axis. It's just minus 6, minus 12, minus 10, zeros. Okay. So if you look at these values, since the place is little for me, what I am going to do is, on y-axis we have only whatever the results that we got on y-axis, these are only negative numbers. Alright, so let me consider the positive y-axis a little shorter and negative y-axis a little longer. Alright, so this is going to be my y dash axis. And this is going to be my x dash axis. I have taken positive side of y a little because there are no positive values for y. And in order to be sufficient, have sufficient space, I have cut down the graph like this. Alright. So 0, 1, 2, 3, 4. And this is minus 1, minus 2, minus 3. And 6, 12, 10, okay. I'm going to consider minus 2. On a scale of 2, I am taking the y-axis. Minus 2, minus 4, minus 6, minus 10, minus 12. Do we have any value other than minus 12? No, right? Okay. So this is going to be 2. On here, I am writing the scale also for your reference. Scale on x-axis. 1 unit is equal to 1 centimeter. On y-axis, 1 unit is equal to 2 centimeters. Generally, we write the scale on upside right corner here. Since I do not have any space, I have written the scale so that you guys will not get confused. All right. So, for the value of minus 3, we have y as 0. For minus 2, this is somewhere here, minus 2 and minus 6. This is here. For minus 1, this is minus 10. Alright. For 0, it is minus 12. For 1 also, it is minus 12. 1, 1, 1. Yes, here it is. 2, for 2, it is minus 10. Look at the way I am plotting the graph. Alright. And for 3, it is minus 6. Okay, here. And for 4, it is 0. Alright. So, I have plotted the points. Now, let me join the dots. So, this is going to be like this. And this is going to go like this. This is a U-shaped graph. Alright. Which is nothing but parabola. At how many points? At how many points is this touching x-axis? 2 points. One is at minus 3 and one is at 4. What are they asked? We are asked to draw the graphs. Yes, we have drawn. Find the zeros. Yes, this is intersecting x-axis at minus 3 and 4. Justify. How do we justify? When we figured out by solving these examples. Using the factorization method, when we solved this polynomial, we got the zeros as 4 and minus 3, and at the same points, the graph is also intersecting the x-axis. Alright, so this is how we draw the graphs and explain how is it going to justify for the factorization method and the graphs. Alright, I hope this is clear for you guys. Within the concept, while explaining the concept, I have told you guys that there is one problem which says that which is without zeros. So I'm going to teach that problem now. So listen to that problem carefully and how am I going to solve this. Alright, so let's get started with the next problem. Here I'm going to start the third bit in third problem, which is p of x is equal to x square minus 4x plus 5. So this is the problem I was talking about, polynomial without zeros. We have to figure out how it has no zeros, and we have to justify the same using the graphs. So in order to figure out the zeros using factorization method, p of x is equal to 0. X square minus 4x plus 5 is equal to 0. If I do it like x square minus 5x plus x plus 5, am I going to get the common factors? X into x minus y plus 1 into x plus 5. So I cannot take this common. And this is like x into x minus y and 1 into x plus 5. This cannot be expressed in the form of factors. So here I am concluding that this cannot be solved using factorization method. Since we cannot solve this using factorization to obtain zeros. So I am going to say that therefore This polynomial has 0. No, this polynomial has no zeros. In the factorization, I have concluded saying this has no zeros as I am not able to express it using the factorization method. So let's try figuring out using graphical representation, geometrical representation. All right. X is equal to 1. Sorry, 0. P of 0 is going to be 0 square minus 0 plus 5. Is nothing but 5. When x is equal to 1, P of 1 is equal to 1 square minus 4 plus 5. 5 plus 1, 6 minus 4 is 2. X is equal to 2, P of 2 is equal to 2 square minus 4 2s are 8 plus 5. This is going to be 1. 5 plus 4 is 9 minus 8 is 1. X is equal to 3. P of 3 is equal to 3 square minus 4 3s are 12 plus 5. 3 square is 9. 9 plus 5 is 14. 14 minus 12 is 2. Then x is equal to 4. P of 4 is equal to 4 square minus 4 4s are 16 plus 5. 16 gets cancelled. This is 5. So if you look at these values, now the question comes up to you guys is why aren't we going for negative values? Because if you look at these values 5, 2, 1, 2, 5, they're going to repeat and there is no way that it is going to decrease so that I can assume that the result is going to be 0. So for the negative values, if you try substituting, you will get even more higher values than this. So for the calculation part, I am leaving it aside and now trying to plot the graph. Alright, so let's draw the table of x, y and x comma y. It has 0, 1, 2, 3 and 4. For these values, we have 5, 2, 1, 2 and 5, which is 0, 5, 1, 2, 2, 1, 3, 2 and 4, 5. So this is the box that is needed for us to draw the graph. So the x value is ranging from 0 to 4 and the y value, the maximum value is 5. So let's plot the graph. Zero, 1, 2, 3 and 4. Minus 1, minus 2, minus 3, minus 4. This is x dash and this is x. Alright. So now here on the y part, y dash we have. This is going to be minus 1, minus 2, minus 3. And here 1, 2, 3, 4, 5. Okay. On the graph you will be plotting it better. Okay. Since I do not have any particular scale here, I am marking it like this way. Alright. For the value of x, when it is 0, it is 5. When it is 1, this is 2. So mark it here. When it is 2, it is 1. Here and here. The intersection part is here. And then 3, it is going up again 2. And for 4, it went up again at 5. So now that we are done plotting the points, let's join them. So this particular expression x square minus 4x plus 5 is forming a parabola, but this particular parabola is not touching x-axis nor intersecting x-axis. Hence, from this graph, as the graph does not intersect, you guys do not write all this in the graph paper, just write it on the notes paper. All right, as the graph does not intersect x-axis, P of x has no zeros. Why it doesn't have any zeros? As it is not intersecting or touching x-axis. Using the factorization method also, we were not able to figure out the zeros for this. So this is the problem I was talking about, which was not touching the x-axis. If you have gone through the concept or examples just before this exercise, you must be aware of this kind of graph. All right. So that is about the third problem. Rest of the three bits are quite simple. You can try exploring them on yourself. Let's jump into the fourth problem. So the fourth problem in the exercise 3.2 is why are 1 by 4 and minus 1 are zeros of the polynomial p of x is equal to 4x square plus 3x minus 1. So how do we prove that a particular value of x is a zero of a polynomial? By substituting that particular value, if we are getting p of x as 0, then the value is said to be the zeros of a polynomial. That is one case. Or the second case is by extracting the factors of this and equating p of x is equal to 0. That way also we can find. So let's solve this. First I am going to teach you the method 1, which is factorization. That is p of x is equal to 0. Let. Alright, that is 4x square plus 3x minus 1 is equal to 0, which indicates 4x square plus, I am going to expand this as 4x minus x minus 1 is equal to 0. By taking 4x common, this is going to be x plus 1, and taking minus 1 common, this is going to be x plus 1. That is x plus 1 into 4x minus 1 is equal to 0. Alright, x plus 1 is equal to 0 or 4x minus 1 is equal to 0. X is equal to minus 1 and x is equal to 1 by 4. This is method 1, wherein x is equal to minus 1 and 1 by 4 are zeros of, this indicates that these two are zeros of polynomial p of x. This is method 1. The second method which we could solve is, now p of 1 by 4, when p, if 1 by 4 and minus 1 are zeros of p of x, then what should happen? P of 1 by 4 should be equal to 0 and p of minus 1 also should be equal to 0, isn't it? So let's try figuring out p of 1 by 4, which is nothing but 4 into 1 by 4 whole square plus 3 into 1 by 4 minus 1. That is equal to 4 into 1 by 16 plus 3 by 4 minus 1. This is nothing but 1 by 4. 1 by 4 plus 3 by 4 minus 1. If I take this into one section, this becomes 1 plus 3 by 4 minus 1. That is nothing but 4 by 4 minus 1. That is nothing but 1 minus 1 is equal to 0. So p of 1 by 4 is 0. Now let's try figuring out p of minus 1. P of minus 1 is equal to 4 into minus 1 whole square plus 3 into minus 1 minus 1. Let's simplify this. 4 minus 3 minus 1. That is nothing but 4 minus 4, which is equal to 0. Since for the values of 1 by 4 and minus 1, p of x is 0, they are said to be the zeros of polynomial p of x. So let us write the statement. So for 1 by 4 and minus 1, p of x is equal to 0, which implies 1 by 4 and minus 1 are zeros of p of x, isn't it? So there are two methods to solve this problem. I have given you both the methods. Which one is easy for you, you can do it in your own method. Alright, so in this video, that's all for this video. In this video we have covered the concept of graphical representation, which is nothing but the geometrical representation of the polynomials. And next to this, we are going to deal with the concept that is needed for us in exercise 3.3. So if you understand the concept well, and if you feel this is content is worth enough, please do like, share and subscribe to your 10th classmates or your relatives who are studying in 10th class. So thank you for watching, and please don't forget to subscribe to Anantha Lakshmi Academy, because only if you subscribe you will get to know whenever I upload a video of 10th class mathematics. So keep watching Anantha Lakshmi Academy and subscribe to Anantha Lakshmi Academy. Thank you for watching.